All right, so we're going to go through two more sets of examples to finish off our lesson on composite functions that we started in class. So the directions for the first example say that if f of x is equal to 2x minus 6 and g of x is equal to 1/2 times the quantity x plus 6, we want to show that f composed with g of x and g composed with f of x, we want to show both of those compositions are equal to x for all x. Okay, now in the next lesson, when we go over inverse functions, we're going to talk about the significance of both of these compositions being equal to x. Okay, so if we want to do f composed with g first, that is f of g of x, which is f of 1/2 the quantity x plus 6. So we're going to plug in 1/2 the quantity x plus 6 wherever we see an x in the function f. So that's going to become 2 times 1/2 times the quantity x plus 6 minus 6. And there's a couple of different ways that you can simplify this algebraically. I think the easiest way to do it is to multiply 2 times 1/2, which is just 1. So that's going to wind up becoming x plus 6 minus 6. So we showed that the first composition was in fact equal to x. Okay, we want to take the composition the other way next. So g composed with f of x, which is going to be g of f of x, which is 2x minus 6. So we're going to plug in 2x minus 6 wherever we see an x in the function g. So that's going to be 1/2 times 2x minus 6 plus 6. When we simplify what we have in the parentheses, the 6's cancel. So this becomes 1/2 of 2x, and 1/2 of 2x is going to be equal to x. So we showed both of those compositions there were equal to x. And again, that's a significant finding for us with what we're going to learn in the next lesson. Okay. Last set of examples we're going to look at. This skill is going to come in handy for us whenever we get into calculus. Okay, so for those of you guys who go on to take pre-calculus honors next year, this skill will be really important for you in the first semester next year when we talk about a topic called chain rule. Okay, so we want to find two functions f and g so that f composed with g is equal to h. Okay, and for number one, we have the function h of x equal to 2x plus 3 raised to the 4th power. Okay, so we have that h of x is equal to f composed with g, that is f of g of x. So when we look at our function h, we want to identify what the inner function in the composition is. Okay, so that's going to be our function g. So when we look at function h, the inner function in that composition is this function right here. It is 2x plus 3. If we want to determine the outer function in the composition f, we want to think to ourselves, what function am I going to plug 2x plus 3 in the place of x in order to get 2x plus 3 raised to the 4th power? And the function that we're going to plug 2x plus 3 in the place of x into is the function x to the 4th power. Because when we take f of g of x, that is f of 2x plus 3, when I plug 2x plus 3 in the place of x, that's going to give me 2x plus 3 raised to the 4th power. Okay? So I want you guys to try number 2, okay? I want you to pause the video and attempt this one here. Identify what is the inner function, what is the outer function in the composition, and then when you attempt it, go ahead and unpause the video and I'll work it through for you. Okay, so when we look at this one here, our inner function is this function right here, x squared plus 1. So that's our function g of x. What function are we plugging g of x into to get rad x squared plus 1? we are plugging that into the function radx. Okay, so you should be able to look at a composite function like we have here in numbers 1 and 2 and be able to identify what is the inner function in the composition, what is the outer function in the composition. Okay, so that's it. That wraps up our lesson on composite functions. Make sure you guys get your homework assignment completed by Sunday night, and we'll see you all in class on Monday. Take care, everybody. Bye.